Miyuyang, my name is Connor McGee. I'm with the Climate Science Alliance. I'm a Research and Data Applications Manager and also the project lead for the Carbon Sink Demonstration Farm, which is hosted at Pauma Tribal Farms by the Pauma Band of Mission Indians. I'll hover over this slide for a moment. So this is a 86-acre organic biodynamic certified by the state of California farm that the tribe had acquired several years ago. It was heavily tractor disked for years and years. It was a polyculture production. There was a lot of outputs, but not as many inputs. The tribe purchased the farm. They saw the value in it being held in organic production for a few decades. And so a lot of the conversations when how to approach bringing this farm back and having a successful agricultural production, as well as one of their economic development projects. The tribe decided to do a number of practices. We decided on working a cover crop into the fields, windbreaks, hedgerows, native plants coming back, the double fold benefits for being able to use the site for harvesting food, fiber, and medicine, and also using it as an education site for youth. And so a few other decisions were made. There's 16 acres of the 86-acre farm. It's held by tenant farmers, the Solidarity Farm, where they cycle about 60 different species of veggie row crops. They're a CSA, Community Supported Agriculture, and they deliver veggie boxes throughout the reservations as well as San Diego County up to around 50-mile radius. And the other 60 acres, the other 60 plus acres, the tribe decided to develop an organic olive orchard. So we're really going to be focusing a lot on the organic olive orchard side. We'll be installing a cover crop, which we decided to be a native grassland with our food, fiber, and medicine. So first we had to decide on which grassland species we'd be using. This is based off of soil type, coarse textured soil, temperature, and precipitation regimes right at the farm site. We're in the frost pocket. We have really hot days. We have the marine influence. Which species have evolved and adapted for this specific site. We kept in mind all the phenology that's so important for pollinators, trying to keep the bloom cycles as long as we can throughout the year so that there's enough forage for pollinators and healthy insect populations. And so these are a lot of our species that we're working with. So we had to get the site ready. We needed to do the prep. The tribe is not using chemical herbicides, insecticides, or fertilizers. We're trying the best to minimize any expenditures that to have our objectives met. And so we were able to successfully organize a prescribed burn. This prescribed burn is helping with the invasive seed termination. We're able to destroy the seeds from all these tumbleweeds and grasses that have moved in. We needed to reduce all the debris to have a clean site for all of our new plantings. And also one of the benefits was that we would have fresh char rate down for a lot of our native species that we would be planting that would be in the soil to help with germination. We worked with CAL FIRE, the Pauma Band of Mission Indians Fire Department. There was some discontinuity in our fuels, so we really just moved fire around the fields. It was a really exciting day. There was a lot of volunteers from the tribe that were out, the fire department, and of course our staff. And we all worked together as a big team to move fire and work it across the fields here. We did a pretty good job, and it was a really successful event, and we were able to get everything done without having to disc, without having to mow, without having to use a lot of labor intensive, cost intensive methods for getting the field prepped. Fire was our most efficient and effective tool, and we were able to use it. So this implement that you see behind you is a no-till seed drill. we're bringing back the soil health. So we're stopping disturbing the soil profile by heavy tractor disking, deep disturbance. So this implement is a custom implement. They're hard to come by, and they're very expensive if you're looking to purchase. So we were doing everything on a lean budget, and luckily through a lot of different contacts and communication, we ended up meeting Mr. Leslie Miller, who has this implement and lives in Modesto. Over 10 hours it took him to drive down with his implement and tractor on his flatbed to come help us seed drill our native seed species. And this is my son Kuala here. He gets to come out to the farm a lot and see everything that's going on, and we get to talk about what we're doing. Best way to teach and share is from firsthand experience, and this also just happened to be the best image that I had of the no-till seed drill. Here's Leslie Miller at work in between our newly planted olive trees, putting in all of our native grassland species, all of our food fiber medicine that we're dry farming here on the olive orchard. And so this is what the success that we've had with our native grassland coming in. It's amazing to see that all of this is doing so well when you consider all of the challenges. We can't plan for precipitation when we're doing a non-irrigated cover crop. We got lucky this year. We did a lot of prep, and it's hard to look at this without thinking about all the work that went into having all these species come in. And it looks different, of course, throughout the year. When some of the other weed pressures do come in, things dry out in the transition from cold to warm species, but this is our glory image. And here we see our forbs coming in, our lupins, our chia, which is really important to our tribal communities in Southern California, and up to the top left, our lupin and red mates, and then of course our poppy. Had a whole nice suite of species coming in after we're able to seed drill these in. Transitioning really fast to our trees and shrubs. We through the tribal working group at the Pauma Band of Mission Indians, we created a large list, a dream list of all the things that we wanted to see more of, that would be more accessible for gathering at the farm. But these are the 40 odd tour species that we're working with for our trees and shrubs, which we're very happy to have found, because our primary filter in doing both the grassland species and the windbreak and hedgerows was availability. It was really hard to come by a lot of different species, and there are some of them, especially the seeds, came with a big price tag. So we had to constantly kind of twist the dials and make sure that we were getting the right amount of seeds in the ground for good germination and good emergence. And same thing with our hedgerow and windbreaks. And again, here the phenology is stretched out as much as we can throughout the year. I believe we have about 10 months of bloom periods here with our trees and shrubs to maximize the pollinator forage. And yeah, almost several thousand feet of trees and shrubs. First thing we have to do, the tribe inherited an older irrigation system. There was some leaks. We had water conservation concerns. In the valley, the price tag for water acre foot averages around $1,600 per acre foot. Water can't be wasted. There is a lot of regulations coming out of the state for groundwater management, which is a great thing, but we can't have any leaks. And so we had to replace some main and sub-main lines. And of course we had to tee off of those to make it out to our windbreak and hedgerows. Here we see we're planting some walnuts and some oaks and some maples here for our windbreak. This is one of our planting days. Deliveries, we got deliveries on a regular basis, hundreds and hundreds of plants. And this is our tribal working crew here, unloading them, getting ready for planting for the following day. Here we see some mimulus, and there's some sages I see, some oaks in the background, juncus, basketry materials, willows, cactuses, prickly pears. And this is another delivery day. We're planting some hollyleaf cherry. We have some buckwheat, and you can see this is on the polyculture side. If you see our squashes growing in the background, this is the solidarity side that's producing all of those CSA boxes for the community. So what does it all look like when you're planting a few thousand feet of trees and shrubs? This is us setting up. There's a tribal work crew on the mule one day, and we're just getting ready for the plants to go in the ground the next day. This is what it looks like when you have fresh plants in the ground. This is on the polyculture side again. This is right now there's strawberries in the ground where you see the field next to the hedgerow, and then in the background you can see the last bit of corn being worked by our mobile chicken coop on electric fences. But yeah, here's our hedgerow. Dozens of different species in here in this short hedgerow that's about 100 feet. On the farm research, this is Starla Madrigal, Pauma tribal member and trained botanist that's helping out today, this day in surveying for seed emergence, and we're checking our weed pressure abatement. Collecting data is one of the most important things we know moving forward, so on a regular basis we're always pulling data so that we have something to stand on to make informed decisions throughout the years. Soil testing, of course, is one of the key components in that, and this is the picture of the farm. We get the marine influence. We're about between 25 and 30 miles as the crow flies from the coast, and on the west coast of Southern California, we get the cold water upwelling that pushes us fog on a regular basis. And so here I am collecting some soil samples in our veggie row crop production. I'm taking bulk samples throughout a bunch of different parts of the farm. And we're able to partner with the University of California, Riverside's Hermospedology Lab, Soil Science Lab. And here I am with a lot of our bulk samples getting ready to start doing some testing. So at the lab, we were testing for soil moisture determination. When we brought the samples in, we immediately measured the soil moisture within the soil to have that as a baseline for understanding what the soil was holding. And then we also continue to do wet aggregate size distribution and stability test, as well as soil organic carbon test. And that soil organic carbon is one of the main things that we're looking at in determining the soil organic matter and the water holding capacity and how much carbon we're pulling down, which is another important element to this project. This is a wet aggregate stability test. So what we do is we test the aggregates within the soil. The aggregate stability tells us a lot about the health of the soil biome. The bacterial, fungal, the plant exudates that bind all of the mineral material together tells us how healthy those populations are. And when there's a healthy soil biome, we're able to pull down more carbon. It's just not having carbon in the soil. It's that carbon being worked in the soil by all of the life in the soil. And so this test, we take the aggregates, and there's 4 sieves that we can measure the size of the aggregates, and we plunge it about 100 times into a bucket of water and see how well they hold together. And that's how we're able to infer the health of our soil. Soil moisture monitoring. So we were able to meet with this gentleman, Mr. Brad Adams, who's a aerometer rep, and we're able to, through one of our grants, we're able to secure these soil moisture monitors. And right behind you on Brad's truck there, you can see the big motherboard, the solar panel, that's going to be relaying a lot of the information from various parts of the farm to our phones, to our apps on our phones and our computers. So to the right, image on the right, you can see one of our towers set up in the strawberry and onion field on the polyculture solidarity side. There we have three monitors in the ground, and that tower is, you can see the close-up image to the left has a little solar panel, and it shoots the information to the motherboard, which shoots it to our phones. And so these are what they look like. They're little gypsum cores. We have them at 3 different depths, so we can measure the moisture in the soil. These are little gypsum cores, and they do a little electronic pulses, and the amount of moisture that's in those cores, the stronger the pulse, the more that we can infer the moistures in the soil. It's called a negative resistance test, and that's how the technology is able to do that. And then those cables shoot it up to the node and shoot it to our motherboard. And that remote sensing, we're able to get instant data on precipitation. We have a rain bucket on the motherboard. It takes our air temperature, it takes our soil temperature, it takes our soil moisture. We know when to irrigate, how to irrigate, at what depths the moisture's infiltrating into the soil. We could check this anywhere in the world really and know exactly what's going on, and we could have all of that data to understand what's happening through the years, and if there's any problems, how we can address them. This also helps us understand, as we raise the soil organic carbon, the soil organic matter that increases the water holding capacity of the soil, how that's doing that, because we'll be able to have all of this data to understand how that soil organic matter is pulling down the water. So here's our glory shot of our cover crop again. You're probably wondering, how could this all happen? Is there just a big pot of money somewhere? Well, no, there isn't. And how do you get all of this sort of technical expertise to move through this project? It's really resource identification in the Southern California region, whose objectives line up with our objectives in this project. And we were able to identify a few different programs. There's the California Department of Food and Agriculture's Healthy Soil Program. Healthy Soil Program is looking to build soils in California to help pull down carbon, to help farmers increase their soil organic matter, their water holding capacity, ability to cycle nutrients, all of the co-benefits across the board that come with having a healthy soil. So it's in this program. So we proposed to the CDFA that we would transition this polyculture system to a no-till cover cropping orchard system. We were the first tribe in the state to get the award, and so that's how we were able to really start our grassland project through the funding in this program. We were able to capture the attention of the science committee of the CDFA. They came down to visit the farm and see everything that we're doing. We're really happy that they gave us the attention on their tour throughout the state and came to visit us. Another program that had just come out was the California Coastal Conservancy's Climate Ready program. This program has a lot of the objectives as the Healthy Soils program. California Coastal Conservancy is looking to build more resiliency upstream in agricultural lands, so that they could help mitigate some of the sea level rise issues and the storm water runoff issues that we see in the coastlands and the wetlands. We were able to be awarded in this program, which helps with a lot of the things that we needed to do at the farm: soil testing, the soil moisture monitors, compost applications, biochar applications, the educational components. We were able to really partner with California Coastal Conservancy to reach a lot of these objectives. USDA NRCS conservation practices was another huge one. We had to address all of our water conservation concerns on the farm, all our pollinator concerns. We wanted to bring up the biodiversity, we wanted to rebuild the soil. NRCS was able to help us accomplish a lot of that. Their expertise, their field office engineers, their field office biologists that paid us so much attention, helped us with any of our irrigation needs. Any questions we had a lifeline with their technical assistance, which we couldn't have done it without our NRCS practices, our contract with NRCS. Our largest partnership, I would say, like what really brought all of it home and together was with our local Indian Health Council, who was a recipient for the traditional practices for wellness in Indian country. That helps us pull the community together, that helps us do outreach, that helps us organize cooking classes, planting workshops, bringing elders out to help with gatherings, organizing tribal youth groups to come out to the farm and talk about things. Our partnership with the Indian Health Council has just been tremendous, and this is a flyer for one of our events you see on the right. Everyone that came from our tribal communities and local community was across all ages, and we had really good engagement. And this is when partnerships really make everything happen. Without having the Indian Health Council and TPWIC be shoulder to shoulder with us throughout all of this, it would be hard to see it all be imagined. So, and with the California Coastal Conservancy, the University of Riverside's Soil Lab, UC Cooperative Extension, NRCS, CDFA, all of our partners and supporters throughout the project, we couldn't have done it without a single one of them. And that's where our strength in partnerships is. And this is one of our planting days. You'll see we had some kids out today. We're planting, I believe this was the Engelmann, one of our oaks in the region that's really unique in its range. It thrives in our area. Coarse texture soils, our temperature and precipitation. This oak has been with us for a long time, and these youth are able to help us come out and plant for a day. It was a really great day. And all of our plantings requires mulch. We need to lay down to help regulate the temperature, the weed pressure, help keep the soil nice and moist during their transplant. So these are our mulch piles. We're really proud of them. And this is our crew out in the fields. All of the day-to-day work, all of the shoveling, the digging, the inspecting of manifolds and checking irrigation lines and pruning. This is our crew of tribal members and visiting students and Solidarity Farm, our tenant farmers. And again, my name's Connor McGee, and I'm just really happy to share a project with you. I'm sure you have lots of questions, and I'd be happy to answer them. My email is here, and also I put our website in. You could see a lot of our other projects that we have at the Climate Science Alliance with our Climate Kids, our tribal working group. And again, my name's Connor McGee. I'm a Research and Data Applications Manager at the Climate Science Alliance. Thank you.